Today's iteration of the FDTD Satellite Applications webinar. We're very happy today to have Doug Kahn from the National Weather Service Forecast Office in Cleveland, Ohio, talking about an unusual midwinter high shear low Cape event in January of 2023. Next slide, please. This is a series of webinars. They are all recorded, and you can find past recordings at the link shown on the page here. Of course, Dan Bykos and I are always looking for speakers. So if you want to talk on a topic where you have something that's happened in your forecast office where the satellite gave you very useful information, or you want to volunteer a colleague, please get in touch with either Dan or with me. Next slide, please. We'll have maybe a 20 to 25 minute talk today, followed by a little bit of Q&A. You can send questions via the GoToChat. Don't press hold, mute when you're not speaking. Take it away, Doug. He's a 4-year veteran of Cleveland. Before that, he was in Huntsville. And if he wants to tell more about his National Weather Service career, have at it. But thanks for being with us, Doug. Take it away.
All right, thanks for the introduction. So today I'm going to be talking about another midwinter high shear low Cape case that occurred across our forecast area earlier this year in January. If anyone recalls, I gave a similar talk on a separate high shear low Cape case in last year for the October 21st, 2021 event, where we actually had several tornadoes across our area. Much less forecasts in advance that event than this was. But still, in my time here, that's just another high shear low Cape case in the last couple of years. So still learning how to forecast these events. And moving forward, I'll show maybe some new satellite products and various SPC mesoscale parameters that you can use in your day-to-day forecasts. So a general outline of the event. I'll give an overview, a broad overview, followed by the SPC forecast progression. Then I'll show some mesoscale environment tools from the SPC Meso Analysis. This will also include some of the satellite soundings from NewCaps, as well as actually a 19Z special sounding from Wilmington. I'll include some satellite and radar imagery from the event. And then I'll sort of conclude with an introduction to Awips in the cloud. Pretty exciting stuff that's coming down the pipeline to eventually replace the legacy West systems in the NWS offices. So some quick facts from the event. We had a high shear low Cape environment that developed across the Ohio Valley and lower Great Lakes region on January 19th, earlier this year. The environment was most favorable for damaging wind gusts. The tornado potential in this environment was more limited than the event that I discussed from 2021 in October that occurred in this area as well. Something that was unique about this event was that there were a combination of both thunderstorm and non-thunderstorm reports across the entirety of Ohio, even extending down into Kentucky. Even some occurrences of hail were found upstream across portions of central Indiana. In comparison to the October 2021 event, this event was moderately well forecast, with an SPC slight risk on day 2, followed by an upgrade to an enhanced risk on the 13Z day 1 update. Now, I will say across the southern half of that enhanced risk area, there were a lack of thunderstorm reports. And we'll get into that a little later in this presentation. As I mentioned in the previous slide, Wilmington did launch a special 19Z sounding, and relatively clear skies allowed for some favorable NewCaps sounding retrievals across the region, and we'll show some of those soundings as well later in this presentation. So here's the SPC progression, the forecast progression from days 3 to 1. In the top left, you have day 3. Really no signs of any severe weather materializing yet. But this quickly changed in the day 2 6Z outlook, where much of Ohio is now in a marginal risk. Followed by the top right image is the afternoon 1730Z update. A portion of Ohio is now in a slight risk. And then in the upgrade to the enhanced risk on day 1, the 13Z, showing encompassing a portion of central and even northern Ohio. All right, so first I'll explain all these loops are from 15Z to 0Z. This first loop here is the SPC Meso Analysis, showing the surface temperature, dew point, and pressure. So the surface temperature in this map, the reds are temperatures that are, I believe, 60 or greater, 60 degrees Fahrenheit or greater, and then the golds are below 60 degrees. Then you have the dew points, which are these blue shaded, or blue dotted lines, I should say. We had dew points that really only peaked just below 50, which is even for a high shear low Cape environment, is fairly low. And you can sort of see those blue dotted lines actually kind of evaporate here across the lower Ohio Valley, and that coincided with that lack of thunderstorm reports across the southern half of that enhanced risk area. And then finally, the pressure. So you can sort of see near the end of the loop, near about 22, 23Z, we do get a 998, 996 low moving northeast across northwest Ohio. So next I'll show the pressure rises and falls. The rises are in red, the falls in blue. Nothing too intense about the pressure falls in the blue, but we did have substantial pressure rises behind the strong cold front, and this likely contributed to some of those non-thunderstorm wind gusts across the lower Ohio Valley. And we're getting close to 5 or 6 millibars in a 2-hour period. Here are the 3-hour dew point changes, and this is probably what contributed a lot to the lack of thunderstorm reports in the southern half of that enhanced risk area. The overall environment was very favorable, but we almost had too much clearing during the day. As you can sort of see, there's this plume of very high dew point changes in the negative. So your dew points are decreasing anywhere from 8 to 12 degrees in a 3-hour time span, sort of extending down from the deep south all the way up through central Ohio. But one thing you'll notice is near the lakeshore, Lake Erie in northern Ohio, northwest Ohio, that change was more neutral. So it was more or less stayed constant in the mid to upper 40s throughout much of the day, and therefore the low level moisture tended to stick around for much of the day. Next, we'll take a look at the low level lapse rates from the day. So really anything in a high shear low Cape environment that's greater than 6 or 6.5 is very favorable for severe weather to develop. But like I said, there was almost too much clearing across the lower Ohio Valley. We had low level lapse rates in excess of 8, even getting to 9 at some points. And this will be important for a parameter that I show later in the presentation, where low level lapse rates are one of the driving factors for the parameter equation. Here's the SurfaceBased Cape throughout the day. You can sort of see that plume of higher surface-based capes sort of propagating northeast into northern Ohio, peaking around 500 to 750 joules per kilogram across northwest and northern Ohio, which is more than favorable for severe weather to develop, especially in these high shear low Cape environments. And also note a lack of surface-based Cape and even some substantial SIN across the lower Ohio Valley, across that southern half of the enhanced risk area, likely owing to limited low-level moisture from dry air entrainment. Now, I mentioned earlier in the presentation about the limited tornado potential for this day. So we sort of knew that this was not going to be in October 2021, just given a lot of the dry air, mid-level dry air filtering into those low levels. LCL heights across the board were generally over 1,000 meters, and with dew points barely reaching 50, we had a pretty decent idea that this would be more of a damaging wind threat more than a tornado threat. And here's the last parameter I'll show. This is one of the parameters that we found in a post-mortem of our October 2021 tornado outbreak that proved useful. So note that in the equation here, you do have low-level lapse rates. And a few slides back, I showed how the low-level lapse rates were in excess of 8, 8.5, even 9. And that was probably potentially a big driving factor in pushing some of these MOSH, modified SHRB values, into the extreme range, so greater than 3. Anywhere that's greater than 3 is denoted by having that magenta color. But as with any parameter, especially, I compare it to the Cape that you see on the Meso Analysis. You sort of want to look for these gradients and even tons of instability. In this case, it's the MOSH parameter, but the best gradient here is across northern Ohio. And you can even see this little tongue of higher MOSH values, 2 to 3, extending north and east into near the Cleveland area and even further east at some points. And this was taken just around sunset, around 4 p.m., so just prior to sunset. And this little box here is actually where we received a majority of our thunderstorm reports. And if you can see down here in central and southern Ohio, really there weren't any thunderstorms. There were showers that produced some non-thunderstorm wind gusts, but that low-level dry air really won in this situation. So now I'll sort of switch gears and talk about how we can utilize some of these satellite products. So in this case, NewCaps. So NewCaps is an algorithm that is used to process some of the temperature and moisture information from 2 sounders, which are onboard 2 polar orbiting satellites, the SUNY NPP and then the NOAA 20. Now, the SUNY NPP will be replaced by the NOAA 21, likely later this year. It was launched in late 2022. So once it's fully operational, it will replace that SUNY NPP. But we'll still have the NewCaps, 2 passes a day. So for the pros and the NewCaps, what I really like about it is that it's not a model sounding that that's based off just one sounding. It does represent the real atmosphere in those partly to cloud-free areas, which we had on January 19th. Now, of course, a con to this is that the data quality is poor or even unusable in cloudy or thick cloud regions. Another thing that I like about it is that you can use the RTMA surface observations to sort of edit your low levels, your surface observations in the soundings itself in Awips. Of course, the con is that these satellites are polar orbiting, so you only get 2 passes per day. Now, for us, it actually works in our favor because we sort of get these passes to supplement the 0 and 12Z balloon soundings. Now, we don't launch any balloons here, but we do have several sites around us, Buffalo, Detroit, and Wilmington, that do launch balloon soundings twice a day. Another con is that there is some significant smoothing, especially in the boundary layer. So don't expect to see some microscale perturbations that you might see in an observed balloon sounding. One thing I did add recently to this presentation is this NewCaps web viewer. So you no longer have to have access to Awips to get the same information. So potentially good for people at home if you're teleworking, doing some Meso analysis to aid in office operations. So here's the, on the left here, we have the red visible band. You can see that really large clearing across much of the Ohio Valley, quite unusual for mid-January. Anywhere where the points are green, the retrievals are good, you have good data quality. And then as you head towards the yellows and the red, your data quality gets progressively worse and unusable really once you get to the reds. And you'll notice the red points are really in those very thick cloud regions. On the right-hand side, we have a toggle between, this is the gridded NewCaps. So what this is doing is taking the soundings and plotting it on a field in Awips, similar to what you'd see in like a model, in a model representation of some gridded data. So we have the total totals. This is the total totals. And then the other toggle is sort of the low to mid-level lapse rates, the 850 to 700 millibar layer. So you can sort of see those higher low to mid-level lapse rates being advected north and east into northwest northern Ohio. That's probably one of my favorite parts about NewCaps is the ability to view this gridded data in a plane, rather than having to sort of pick and choose which soundings you're looking at. But they both have their pros and cons. So first we'll take a look at a point sounding from NewCaps in Sandusky, Ohio, which is just west of the Cleveland area, right along Lake Erie there. So the top box, what you're seeing there is the actual raw NewCaps point. Now, recall earlier I did mention that you can adjust the surface observations in Awips using the NewCaps data. So this bottom box is showing that edited readout. Now, instead of 0 instability, we have just over 400 joules per kilogram, which is more than sufficient for severe weather in a high shear low Cape environment. Now I'll contrast this with a point, NewCaps point closer to Wilmington, Ohio, and then we'll also compare this to an observed 19Z special sounding. So the raw NewCaps had the surface-based instability of 40. That number only rose to around 100 when taking into account the surface observations at the time. Now comparing this to, here's some of the, this is what the actual sounding looks like. So on the left we have the Awips sounding from Sandusky, and on the right we have that N-sharp from Wilmington. So note the general shape is very similar. The only real difference is once you get below 850 millibars. The low levels are much more moist in Sandusky versus Wilmington on the right. And that's really only accomplished with implementing those surface observations. So now we'll sort of compare that NewCaps sounding with the 19Z special sounding from Wilmington. Here, that star denotes where the Wilmington office is, the general location, and the WPC surface analysis at 18Z, so just 1 hour prior to the special sounding at 19Z. Note that approaching cold front and occluded front with the low moving northeast across Lake Michigan. The general shape of the observed sounding, now note those microscale perturbations that you're not going to get in NewCaps. As I mentioned in one of the cons, it does smooth out some of those boundary layer or mid-levels just because of the resolution in the temperature and moisture levels. But the general shape, we're comparing it to the sounding on the right. The general shape of the low to mid levels is fairly good. Even the low levels, once you're take into account that below 850 millibars, when you take into account the surface observations. And note the dew point, surface dew point at the time here is only 41. So it's pretty hard to get severe weather when your dew point's that low. And take a look at this readout box. With the special sounding, we have a SurfaceBased Cape of 123. With the NewCaps sounding here with our edited or adjusted data from the surface observations, we got 116. So fairly good agreement between the NewCaps adjusted data and the actual observed 19Z sounding. So now I'll discuss some additional satellite imagery that may be useful. This is actually the GOES 16 derived products. So what we have here on the left is the lifted index, so the GOES 16 derived lifted index. So the darker yellows getting into the golds and even reds mean that you have lower stability, and vice versa for higher stability once you're getting to those blues and lighter yellows. So you'll see as the low pressure approaches northwest Ohio, you have increasing lower stability across northwest, northern Ohio along the lakeshore, coincident with cooling cloud tops. So I will mention these cloud tops as infrared imagery is user defined just because of the cool season. But that's something that I do on occasion, is user define some of these products, whether it be the infrared satellite, whether it be the GLM flash extent density, based on season dependency. So during the warm season, these reds might be more like magentas, just because the cloud tops would be a lot cooler. Now on the right-hand side here, we've switched from now lifted index indice to SurfaceBased Cape. The SurfaceBased Cape I've used a little bit in Meso analysis and warning operations. It did actually show a small area of modest SurfaceBased Cape across northwest and northern Ohio. Really, if you look elsewhere, there wasn't much at all of any instability, and that's probably owing to that lack in low-level moisture across much of central and southern Ohio. So what actually happened? So I mentioned all those non-thunderstorm wind reports. Well, that other here in the legend is just that. Those are all non-thunderstorm wind reports, and look how they sort of match up with the low track and where the highest low-level moisture was noted. So across our area, across northwest Ohio, northern Ohio, is where we actually got all of the thunderstorms and thunderstorm wind reports, whereas all the other reports in the gray were more associated with the cold front and those pressure rises behind the cold front. One thing that was interesting, that there were even a few hail reports upstream across Indiana. So I thought that was pretty interesting. Possibly we can owe that to some of those steep low to mid-level lapse rates like we saw earlier in the gridded NewCaps product. And then here's the radar imagery throughout the event, starting around 4 p.m. and lasting through 9 p.m. So we can see a few of those severe thunderstorm warnings across our area, overlaid with some of the LSR reports. We had a pretty good line of thunderstorms moving east across the Cleveland area. Now, one thing I wanted to also mention is the lack of convective intensity towards the southern flank of the line. Really, more or less were just some glorified power showers, as you may call it, and that may have resulted in some of those higher wind gusts as well. But there was much less lightning the further south along the line that you went. So now I'll sort of switch gears again and talk about something new and exciting that will potentially make its way into the weather service here within the next couple of years. So Awips in the cloud could eventually replace some of these legacy West system housed in the forecast offices over the next couple of years. It offers a bunch of utility, much more flexibility in being able to archive and complete some of these West cases, West trainings. No more having to sort of rush and archive an event a day or two after it occurred. Now you can sort of pick and choose. I think you have up to maybe 30 days. There's a lot more details that I'm still not completely familiar about, but I was really excited to sort of test this out. And I was even able to pull in some of my perspectives from when I was on the warning operations desk that day. So this is actually my left panel of my perspective. And this is one of the tabs that I use, which is very similar to if you've taken RAC. This is a very similar 9-panel to what you see in RAC when you go to Oklahoma. So it's a 9-panel of various dual pole and base reflectivity, velocity products. And then on the right, on the next tab here, I actually have a 6-panel of our surrounding radars. In the past, this was actually not as useful as it is now. We're actually getting the lowest several slices of all data from surrounding radars now, the super res actually. Before we would have to request this data, now we're getting it through the SPN. So this is useful if you have a really bad angle on a storm approaching your radar. You want to see what the storm looks like on any of your neighboring radars. Maybe you can see a convective core go up earlier using some of the other radars. So I've been using this procedure more and more often, especially with storms that are further away or maybe less clear cut like they are in these high shear low cape cases. Now, probably my favorite part of my 2-panel display is this sort of integrated MRMS, TDWR, and satellite perspective. So in the top left, it's actually a 4-panel from our closest 4 TDWRs. In this case, I just wanted to highlight the storms coming into the Cleveland area, so I utilized the TLVE reflectivity and velocity. In the bottom left is my MRMS display, which includes on the top left, we have MRMS reflectivity. It just happens to be composite reflectivity in this case, but it can be switched out for -10, -20, depending on your needs. On the bottom left, I have vertically integrated ICE, which is good for picking out some of those more intense cores, especially during the warm season. On the top right, it's something that I'm experimenting with. The hail tracks, or the mesh tracks, MRMS mesh tracks, those are good for sort of seeing what a storm has done in the past and its general motion. Now, overlaid this, I have the GLM minimum flash area. So the theory behind this is that the smaller your flashes, they're younger updrafts, potentially stronger updrafts. Now, in a line of storms, this can be particularly useful because you can see where your mature storms are and where your newer storms are, potentially your stronger cores, your stronger updraft cores. Something that you might not be able to really discern in the flash extent density. Now, it does show up pretty well in this case. In the bottom right, I'm showing the flash extent density. Although once again, I did user modify this down based on this event being in the cool season. And then on the right-hand image, we have the infrared satellite overlaid on top of the nighttime microphysics satellite. So what I've done here is I've actually zeroed out all of the infrared that is warmer than -25 C. And this is to get the best of both worlds. You can do the same thing during the day with the red visible band to sort of get all of the cloud information, the higher resolution of the red visible band, while also getting your cloud top cooling information on the IR band. So I thought it was just something cool, using your user modified color tables just to sort of grab some of the additional information you might miss if you just used one product at a time. And of course, this is overlaid with your convective warnings and surface ops. So in summary, we had a high shear low cape environment across the Ohio Valley, Lower Great Lakes region, and it resulted in numerous thunderstorm wind reports, in addition to some non-thunderstorm wind reports, which were mostly confined in that southern half of the enhanced risk area. The MOS parameter, that modified SURE parameter, proves useful once again. Recall that it is not just for tornadoes, but any severe weather, including damaging wind gusts. So very helpful in this scenario. Relatively clear skies allowed for quality satellite retrievals from NewCaps, something that we don't usually get here in the winter, the cool season. But we also had an aid from the 19Z Wilmington sounding, gave us that increased confidence that there was a lot of dry air present in the low levels. And then finally, Awips in the cloud did show utility, and made me excited for a future replacement for our legacy West systems at the WFOs here. So with that, I'll end here and take any questions.
Awesome, thanks. I do have one question. I'll take prerogative as an organizer. I was also really surprised. I mean, I grew up in central Pennsylvania where it's always cloudy in the winter. So to see clear skies in January in Ohio just seems very unusual to me. But I'm wondering overall, how often do you have clear skies, 18Z-ish, as NewCaps, as NOAA 20 or 21 is overflying you, that you're going to be able to use NewCap soundings because of those clear skies just generally? Is this unusual or happens kind of frequently?
Yeah, I definitely would say it's unusual. Although for our bigger severe event days, we typically have that morning convection, that morning cloud cover, and for it to be a really big day, we typically do see at least some degree of clearing across our area. If it's going to be a pretty scattered severe weather day, it just happens. Really, what we need is it just needs to fall in line with that 18Z polar orbiter retrieval. If it happens an hour earlier or hour later, then we may be out of luck for a NewCap sounding. But it seems like that 6 to 7Z and 18 to 19Z window covers us pretty well, especially considering the data gaps between 0 and 12Z from our neighboring balloon soundings.
Thanks. And just one comment on NOAA 21 NewCaps. I believe that's not going to be operational until late 2023. I mean, no earlier than late 2023. So end of this year before NOAA 21 NewCaps is going to be available. If there are any people who want to ask questions, I don't see any in the chat right now, and I don't see any hands raised. So if anyone wants to ask a question, okay, I see something. No. I do see that it is after 1730 UTC, so you all have Doug's email. So of course, if you have questions afterwards, feel free to send them to him or to Dan or to me, and we'll forward them along. I'd like to thank Doug again for his talk on this interesting event and the use of NewCaps and the Meso analysis to help in the analysis to really anticipate what's going on a little bit better. Thank you for attending today's FDTD webinar series webinar, and we'll see you at the next one.
All right, thanks, Scott.